Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we have a service call for a Johnson Controls water-cooled heat pump. Thank you to everyone tuning into Jumperman Tech. We have a service call for this Johnson Controls unit. Looks like it's two separate units here. 1, 2. Let's see, AC 1-1. This is serving the lobby. Looking right now, we must have, okay, what we got over here, got some sort of pressure difference, about 175 and 195. All right, so we got water coming to this unit. Looks pretty serious. That's all open. I don't think there's any actuators unless it's in the unit. Oh, there's a strainer here that might need to be pulled in, might need some maintenance. So let's use our eyes and ears, guys. Eyes and ears. We got belts, 850, 2 pieces, huh? Right now I got my thermometer in the supply duct, I believe, right? We'll see. There's 2 ducts here, but I think these are 2 supplies. It probably is a supply because they got a, so there's a coil there. It's like a hot water coil in that unit, right? What is that? HW, right? Yeah, hot water coil 1, okay. So let's see what's going on. This thing is all taped up and junked up, but they said the lobby was really hot. There's 78.1 degrees in there, and there's also 71 degrees in there. Let's open up these covers and see what's going on. Let's see what's up with this. There are more screws over here. Yeah. They're barely like visible. Who did this? They should come off. It's weird because the other side won't come off. Let's put that over there. Is there screws in here? Why doesn't this come off, man? I know the fan helps to work here too, but geez. Anyways, what we got here, this is a heat pump for sure. They have a lot of water source heat pumps. I see it's a water-cooled condenser coil, 4-way reversing valve, compressor, got high and low pressure controls. Let's open this up, see what we can see. I don't think that's working either. I don't think none of this is working. Where's our control panels? Up here, it's gotta be. And the fans are on the side. I got a fan here, got a fan there that's making noise. What is this? It's something else. All fans are running, so that's okay. We can take a look at the condition. Oh, right there, look at that. I see some controls. It's probably down here. Wow, fooled me. And there actually is an actuator for this water right here. I think it's dusty, but it's a Johnson Controls actuator. Why is it just like this? Oh wow, I don't know. But we gotta know if they're moving water. Anyways, let's open the control panel. Let's open up the control panel. Come over here. Yep. Let's see what's going on here. Let's open up this panel. Let's see what's going on. What kind of controls we got in here. All right, we definitely got some controls in here. Got 3. We got 1 contactor over here, and that looks like that operates both fans because those are running. And these are probably the two contactors. Let me see that. This one on the right looks kind of burnt, man. That contactor is done. Come on, tell me it's the 24-volt coil. I just picked up 2 of those today. 3-pole as well. Yep. I think it looks finished, man. But that might not be what's holding me out. Look, I got 2 wires here. Oh shit. This is the fire cable. Hey, it's someone else. Fire cable is disconnected here. Oh my God, dude, there's gonna be a fire in the lobby trying to get out of here, man. And then we got 2 wires disconnected here. Who's this? Orange and gray. Did it say anything on there on this board? I gotta do some research. Why, you know, what's going on over there? This gotta be low voltage, my thermostat. Hold this real quick. Let me see. Who's coming in here? Looks like honestly a true mess. Anything? Oh, there's a little terminal strip here. Let me see that.
Yep.
There's a terminal strip here. XL, man, there's some strange terminations. We gotta see what's going on here. Are we even calling for cooling? Man, how much low voltage cables do these people run in here, man? This is insane. This doesn't make sense. And then these wires, these 2 disconnected, might be to shut the unit off, because we got these are 2 male connectors. That's a male. Well, that's a male. Oh yeah. No, this is female. And you got 3 male. I don't know, but you see there's a taped here. This is probably where it used to go. So this guy probably gets connected there for fire safety, but there's some other things going on here. All right, volts AC. The coil is in the back for those units. Let's see, can I even get to it? Are they calling? 0 volts. Back here, you should have voltage, right? 24 volts. And we have it because it's calling. Over here, I don't know if I can get in there. I might need to turn this unit off so I can pull it a little. But I might have something there. So I'm not getting coil voltage on these thermostats. Let me see something. Started. And that started. Something is preventing us from coming on. Is it our thermostat? This is the strangest thing. If you look in here, there's a little terminal block for our low voltage. Sure, I see that. And this fire cable is disconnected as well. Unreal. I gotta take some pictures and show management here. Can I see? Oh, I see the green wire here is G. Who's here? OB is this orange wire connected. Whoa, Y1 is the yellow, okay? Common, get my face out of here. Common is the black wire. Chris, hold this. So yellow, we gotta follow this. But the yellow from here is cooling, right? Y1. G is fan. And what color wire was that again? Black. There's 2 blacks, and that's common. So this cable is being fed common, and this is being fed common. We need some. Where does this go? Does it come back down here? Because there's 2 things here. The yellow is not being connected here, so we don't have cooling through this. Let's see. I need to find out where this goes, but we honestly need to check here. So over here is actually going to be this fire cable. Over here is where all the low voltage wires comes in from. I mean, who in their right mind did all of this? This is insane. But anyways, I see a terminal block there with some terminations, right? That's gonna hold. Anyways, right now, let's check between R and C. Make sure we got 24 volts. It's gonna be hard to see, but here's R and this is C. And we have 24 volts. So the transformer is doing its thing. Next, let's check between R and Y. Shows 0. So that means that R is our main hotline. It is sending power to Y. That's why there's 0. If it's not, you know, then it's not calling. So it's calling for cooling. Something shuts you down here. Our fans are running. Is this actuator open? Because if it's closed, it would have shut you down on high pressure. All right, let's see what we got. Here's one of the circuits. Got a nice Copeland compressor here. Nothing is going. Seems like it's running, man, but I would love to really know. Anyways, let's see. Something's holding us out. What kind of safeties do we have here? Low pressure, high pressure? I don't really see anything else. A thermostat's calling, given everything is wired. Okay, this is a 410A system. We have just over 200 pounds standing pressure, like 200, 205 pounds per square inch right now with the system off. Let's see, for 404, no, 410A. It says we're about 70 degrees, and I'd say that's about the temperature that's here, so. Okay, we have another circuit there, we gotta check that. These, you don't lose refrigerant on them, so that's great. Let's get the probes, put it on the other circuit. I have my digital probes here. Let's get it on here, see if we see anything. But yeah, I'm suspecting right now those pressure controls. What's going on? But why is both down? Okay, we have a standing pressure of about 210 pounds per square inch on this side. I got the digitals on that side. That one about 200, 205. Over here 209, 210, 210. Seems normal with the temperature, at least that's in here as far as ambient. Why did this shut down? Let's turn off the power.
Sure.
Oh, sorry. If anything, maybe we gotta reset this thing. But right now,
yeah.
Let's turn this off. That belt looks good. We gotta check the next one. Maybe that's okay. But right now, something is holding us out.
Sure.
I got 0 volts between R and Y, so it should be calling for cooling. Our standing pressure is okay. Thing is, why are both units off? What's in common of both units? And that's these water pipes. I wonder if this actuator is opening or closing. I didn't notice it, but right here it looks like it could have been bypassed. Because if you read here, it shows 100%.
Yeah, I saw it.
And there's an arrow. So maybe, do you feel water? I don't really feel water. We gotta take a look. We gotta watch. This was here before.
Yeah, that's what it's now.
I wonder if this is water. Maybe our high pressure locked us out at some point. But let's reset this unit and watch our pressures. All right. I don't really feel any water. It seems like quiet. Like you would feel water kind of rushing through.
Yeah, just like it's like vibration. I don't know about this one. That's the set. Yeah.
Look, it says 100%, so it should be open, right?
Yes.
Let's see. Put your hand in there. See if you feel a difference with water moving. If this is at 100%,
Yeah.
maybe it's just bypass, but see if you feel anything. I don't hear anything.
No.
I don't hear no water. Could they have been doing maintenance on this and shut the water down at some point? Those valves are open. It's coming off of here. And they come this way into a different room. It actually feels kind of warm on these pipes. But over there, it's kind of cool. It's, you know, it's strange because I don't feel water movement, right? So what's in common with both? If there was a low pressure switch or something, or high pressure switch, one of them would probably got a shot down. But both of them, I don't know, man. It seems a little bit weird. Both evaporator fans are running.
Mm-hmm.
That's not an issue. The contactor's pulled in,
Yeah.
but something's holding us out for our high pressure. So we gotta watch this arrow.
Okay.
I have a feeling it has something to do with this actuator because that's what's in common with both of these units.
Yeah.
All right. Yeah, it's some weird box inside there. I don't know. Be careful, I'm turning the fans on. Keep your head out of there for a sec. All right. We might need to reset the thermostat at the at the front desk.
Yeah.
And take a look at this. But you know what? Let's get this cover back on
All right.
before this thing actually does start. Our issue is gonna be between the controls and these compressors, man. Fans running, this unit just reset. Compressor never even tried to start. Look, this valve is spinning.
I see.
So it's changing. It's going from 100% to going slower, but it was stuck at 100%. To be honest with you, I feel water now. Maybe 100% is 100% closed. I don't know. But this thing is doing something now. Let's give it a chance. You did that?
No.
Oh, you see right there. So this opened, and now it's started. Started on its own. We'll give it a little reset. We got 67 degrees, 66. It's in cooling now. What happened here? Was this thing jammed up? So it needs to be open. It has to be on 0 for water. That's weird. Well, wouldn't you think 100 is like full flow? This line is kind of hot, man. So this is probably the inlet down here. Yep, inlet, outlet, you will feel hot. It ain't too bad. Got a 350 back with about almost 115, 120 head. I'm sorry, about a 350 head with around 115, 120 back pressure. That's pretty good for 410A. And look, we got 62 degrees. Got 62 degrees. The other circuit is not running. You probably don't need the other one. So this left, oh no, this one here is this circuit. The one in the middle is on the right, and that's for the fans. It's gotta be. What happened here? You see, that's weird. I touch this thing, and now my head pressure is going crazy. Let's go this way. Oh man, this thing is breaking on itself. It needs to open. This needs to be open. This thing shut off on high pressure, man. Look, it's shutting down on its own. At 100, look, I'm at 400 pounds of pressure. Climbing, 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 climbing. Look, now it's coming down. No, we're almost at 450. This valve isn't opening. This actuator. It opened before. I'm forcing it open by hand myself. Wasn't able to catch this one below. You can see where it's already above 500 psi. It's shut down on high pressure. It's because this actuator is not opening. Right now, this is the other circuit. You see almost 500 pounds of pressure. Yeah. So right now, like I called it, there's something in common. It was the water that's in common. Why is both circuits down? I took a screenshot real quick. 572 pounds of pressure on the high side. So these things are shutting down on high pressure, and that's because this water is not open. Jeez. So here's the actuator wires pulling up through here. Comes up this guy. It goes behind here. And you know what? You can't get to that. There's a cover there, but that's not gonna. See, there's a wall behind there. I wonder if it's not connected even. Could be hacked, who knows? or goes into this harness. I need to take out that box to see where those wires go. I got the power off, but look at these filters, man. Oh man, they're done, man. Jesus, these people need some maintenance, man. Look how you get to the filters here. Some tape holding up with a hole in the duct, and that thing ain't even on there right. That coil is dirty. Oh man, it doesn't surprise me here. How much dirt is in there? Oh man, what the? So here's a terminal there. If you look at it, our cable, it goes to 2 terminals. I look at it, goes to common 1, okay, but then X1, and there's nothing on X1. There's nothing on X1. Christian, come in for a second. I'm trying to see. Yeah, that's if this is it on this diagram, you're not gonna see it, but this is an isolation valve. It says black and gray. Black goes to C. The other one goes to X1. But there's nothing on there. How can it be? If anything, when it calls for cooling or for heating, you know, it should power up. But it says 24 volts, so that's the 24 volt supply there. I took off the 2 wires. Common is this guy, top left, connected. And if you look at it, X1 is right here, and that is loose. That means something was here before and somebody took it out. That's why it's not even doing anything. What happened here? And this switch is disconnected. It's a hack job and a half. What makes sense to me is that, to be honest with you, let water just run through it. It's a closed loop anyways. They can have water in and out all the time. But what makes sense is maybe if you're between common and then maybe Y, because it is a heat pump. So if they want cooling, Y needs to be energized. If they want heat, and then if they, you know, if it's satisfied, it'll close the valve. Then what happens in heating, you might get power on Y and OB. So even for heating, Y is connected. Once it satisfies, it turns off. It should work that way as well. But we can't say this control is bad if we're not getting 24 volts to it. So let's start with that. I just came to a realization this whole unit is completely hacked, and this thing probably didn't work right for a long time. I only came here for the first time next week in this building, last week. Anyways, right now, common is common. The X wire is loose. There's no terminal there. It's just a terminal block. It's just a piece of metal. So if there's no wire there, how can there ever be power? And there's 4 wires. I cut this here because I was trying to check for power. I couldn't get to the behind. I cut this here. We're not getting power. We can't say the actuator is bad with no power. We can never get power. And then the other 2 wires, if you look, one is like red, orange or whatever, orange and red. They're both cut. This thing never worked. It never worked. And it's just unreal. I'm probably gonna have to just customize this to work on my own. I'd rather put something simple, not with all this, you know, modulating or anything. We're just gonna put straight 24 volts. You need water, 24 volts. Once it's satisfied, spring return, closes back. And that's it. That's how you're gonna have an actuator in the system, or just get rid of it the whole time. Just let it freaking go. You know what I mean? Just flow water through there. It doesn't even matter. But an actuator is the way it was. What pipe? What size pipe is that? Like 2-inch pipe. Yeah, it's 2-inch. We need a 2-inch valve with a regular actuator. We do have enough pipe here and there. I can make this happen. Customized. You already know. But real quick, I want to see what if I put 24 volts to this? Let's have this open. But then again, it's never gonna work right because it has to modulate, says through the gray and orange, but they're cut. The 24 volts might just be powered just like all the way there, like it's between. But you see over here, I don't know. If we look here, it says motor is red and black, and then the spinning is between gray and orange, but it, depending on how it calls, it'll open or close. I mean, all right, right now I'm not even gonna mess with that to try to get it to go, because I can't see where the other two wires go. Who put in this actuator? Who did this? Right now, what I would do is bypass this, have the water flowing all the time. I gotta come back, put a new actuator valve and actuator motor, right? Actuator valve, actuator motor. It's just a big actuator here, right?
Yep.
We gotta get the pipe size, and on here it says 2 inches. So if we put 2-inch control there, valve, we're gonna be all right. And look, this one is threaded on. If anything, I can cut it, cut here, spin this whole thing off. Yeah, and get it going, man. Unreal. What is going on? Let's see. Anything else holding us? You hear that? Yeah. If we spin the actuator, we're gonna have water flow. Whoops. What happened? Right there. If I leave it like that, oh, this is, you probably gotta take this off. Let me just get this right. If we take this off, probably, this is probably on the valve body. Yeah, I think this, gotta take this off. If anything, I'll leave it bypassed, and I come back and you guys gonna see me pipe in a new valve, new actuator, and I'm gonna wire it my way, man. Yeah, hold up. How can I, let me get this screw off. There's a screw in there. Can I get rid of this? I'm gonna put this on there, and we're gonna screw this down. We're gonna screw this down, and we're gonna bypass this. Oh man, what a hack job and a half, man. You know, this is a 5-year-old building and there's nothing but hacks, man. Let's see, is there any way I could do this? Just, let me get, I don't wanna do channel locks. I might need to spin it with this. Hold up. I might need to spin it with this and find where, unless like, oh no, there we go, there we go. Let me get adjustable.
Gotcha.
Let's do it. Unreal. Adjustable. That's why I wasn't feeling water there, and now you're gonna hear it. Closed. Closed. I think there's just a quarter turn here. Let water flow. Now we got water flow. Watch, these things are gonna stay on, man. But another problem is the thermostat I have over there in the lobby, that thing is like locked out. I unlocked it. Next thing you know, it seems like it's on a schedule. I got rid of the schedule into the programs, and it's made by Reliable Controls, and it's nothing but reliable, man, I tell you. Nothing but reliable. That's like a weird thermostat. So new thermostat. I actually got a basic one in the truck. That should do it. And a new actuator with some control work. I gotta get this wired properly while we're here. We gotta do a full preventive maintenance, right? We gotta pull the strainer on those things. Who knows when that was pulled? There's a strainer right down there. We gotta change the filters. And while we're at it, just put them new belts, brush down the coils, clean some of this up. I mean, look at this, it's only 5 years old. This thing looks like a junkyard. Unreal. It's gross, man. Need a cleaning. All right, everyone, we're gonna wrap it up from here. There's something very strange going on with this unit. Even after I got everything disconnected, like the actuator, we got water going through. We're setting the thermostat down to 71 degrees. It should come into cooling because it's warm in that hallway. Next thing you know, this actuator up here opens, and there's actually a hot water coil in here. Also, as far as here, it's pulling in air from outside. We're getting 80 degrees just on here because it's bringing in fresh air out from outside. So it's just a whole mess. I have no control with the thermostat, and unfortunately it's not a regular thermostat. It's a BAC net thermostat. That's something like, there's got to be like computer controls or something, like building management system connected to this, because I don't understand what's up with all those wires there. There's literally like 8 wires or something connected or more over there, and it's showing negative and positive, then it's showing net. So it's got to be hooked up to some sort of computer system. But as far as right now, we're just gonna wrap it up here. We're gonna have to come back to Truly, install a new actuator with a new actuator valve properly, and somehow go maybe call tech support for whoever makes that thermostat. It's a Reliable Controls thermostat. That's the brand. Never heard of it, never seen it, and there's just way too much going on. And right now it's almost 9 p.m. We had a crazy call earlier. It's time to go home and wrap it up, come back on a fresh head. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. I'll catch you all next time.